All right, this worksheet is going to be chopped up into a few different videos. The first one here is going to be over the front side of this first paper, which deals with the periodic table and review as to how the periodic table is organized, the different particles that are in my atoms, where the particles are located, and things like that. So the first thing we're going to start off with is labeling your periodic table. We did this last chapter with the electron configuration. Now we're going to label it to hopefully make a little more sense with that stuff, as well as tie that into our different radius trends and ionization energy trends. Okay, so as you can see, there are the 4 different blocks on the table. Okay, so take a second, pause the video, label what I have labeled, and then I'm going to go through and explain these 4 different blocks. Okay, you start with the left-hand side there. This left is the S block, my one's in purple. Okay, and as you can see, it starts off with a 1s in the first row, then it goes to a 2s in the second row, and then a 3s. Notice how it's both S1, S1, S1 as you go down. Okay, so as I go down that first group, they're all S to the first. I would keep going if I went down to the bottom, and it would be 7S1 down there at the bottom. Okay, that's because, again, remember, like last chapter, S has 2 electrons that it can hold. All right, the same thing works with the P block over here on the right. Okay, it is 2P1 to 2P6, as you can see there on the first row of P's. Okay, again, notice how if I go down the row, it is P to the first, and then it continues on 2P1, 3P1, 4P1, 5P1. You go across, it should end into the 6th, so anything in that last group should have something to the 6th. If you go down to the bottom, that would be like 7P to the 6th, and if you're working towards the left, that would be like 7P to the 1st. Okay? You go to the middle, and your D block will be the same, except for it's one number lower. You start off with 3D1, 3D2, all the way to 3D10, here with 30. Okay, and if you go down the group, again, it's the same thing. They're all going to be a D to the first, or D to the second, D to the third, whatever it is, depending on which group you're in. Your F then down at the bottom will be 4F to the first, all the way to 4F to the 14th. Okay, and again, same thing works down those groups. They're both going to be F to the first, F to the second, F to the third. Okay, so if we look back on our worksheet then, okay, that first question after the label your periodic table says, what does every element in a group have in common? Okay, and if you're looking there, okay, like I just stated a second ago, every element in the same group has the same exponent. So these are all P to the first, so those are all the same exponent, which means they have the same number of electrons in their orbital, and then they have the same number of valence electrons. You can also tell your number of valence electrons by what group it's in. So if it is in over here on the right and I'm in group 16, that would be 2P to the 4th. So you would think there might be 4, but there are not. There are actually 6 because you still have the 2 S's along with the 4 P's. So it actually goes along with your group number. You see how it's number 16 and there are 6 valence electrons. So you kind of drop the 1 there and then that's how many valence electrons you have for that particular group. Same thing would go for group 18. I would have 8 valence electrons. If you're over on the left-hand side, I would have 1 valence electron for everything in group 1 because you are in the first group with 1 S. So you kind of have to have the S's and the P's to be your valence electrons. When you start talking about the D block, most anything in the D block has 2 valence electrons. It's just, it kind of changes. And we'll look more at the number in our next chapter. For right now, you can kind of tell that they should be the same number of valence electrons in every single group because they're P to the first or P to the 4th or P to the 5th going down the group. All right, the next question then asks, what does every element in a period have in common? So if we ignore the D block, okay, every element is in the same, or every thing with the same row is dealing with the same number, the same coefficient. So if I look at that 3P, I'm in the 3rd row, and look at that 3S, I'm in the 3rd row, those are both 3's. So other than your D block, which is off a number, and your F, which is off 2, okay, if you're in the same row, you have that same energy level, that same coefficient. So you should have those 2 things filled in on your answer sheet. So that would be those first 2 there. We're going to kind of work through the next one. I'm going to be flipping back and forth between different things. Okay, so the next question asks then, what are valence electrons? Valence electrons are the outermost electrons. They're not part of that full energy level. So when I talk about valence electrons, that means they are the ones on the outside. That's why when I said you're in the 16th group, you have 6. Okay, those are the ones on the outskirts that are not part of a full level. If you're looking at the difference between a 1s orbital and a 2s, this is from last chapter. Okay, all this stuff is from things you should know before. A 1s and a 2s, the 2s is just farther away from the nucleus. It's a larger orbital. So remember we said that 1s would be a small sphere, that 2s would be a bigger sphere, a 3s would be an even bigger sphere. So when we talk about the difference between a 1s and a 2s orbital, you're just dealing with size and the further away you get from the nucleus. This next one then asks about the charge of an electron and a proton. You should have done this your freshman year. Okay, electrons are obviously negative, protons are positive. And it may sound like an easy question, but then it's going to lead us into all the rest of these. Okay, where are electrons located in your atom? Where's your protons? Electrons are on the outside of your nucleus or surrounding your nucleus. They're in that electron cloud, okay, where we're dealing with all these S's and P's and D's and all these crazy shapes for where they stick electrons. Okay, electrons are always on the outskirts. So we have valence electrons are on the outside of an atom. Okay, protons are in the nucleus. Okay, they're in our center with our neutrons. So electrons on the outside, protons in the middle. These two are going to help us out with this next trend we're going to talk about with atomic radius. Okay, what particles do you add to an atom when I go from sodium to aluminum? So I go from sodium to aluminum, we're going to ask what is added and where is it added. So we're also going to talk about the particles we add when we go from lithium to sodium, and then the difference between the two. So if you want, you can copy down what I have, okay? So pause it, copy down what I've got, and then I'm going to kind of be shifting back and forth with my screens, okay? So when I look at sodium to aluminum, sodium has 11 protons and 11 electrons. Aluminum has 13 protons and 13 electrons. So you're adding 2 electrons and 2 protons if I go from sodium to aluminum. So the thing is now, where are those being added? So with sodium to aluminum, okay, the protons are being added to the nucleus. The electrons are being added to the outside. Well, the same thing goes from lithium to sodium. Lithium has 3 electrons. Sodium has 11 electrons. Again, protons being added to the middle, electrons to the outside. But the big difference here is that last sentence. The lithium electrons are closer than the sodium electrons, because I'm dealing with a 3s versus a 2s. 3 is bigger. So sodium's electrons on the end should be farther away. And that's that following question there that asks what's the difference between the two. Protons are in the same spot, but electrons in sodium are added to larger energy levels, a 3 versus a 2, further away. And the last question that's going to help us out here is what's holding the atom together? Well, you have to have opposites. Opposites attract. I've got a positive nucleus and a negative electron. Okay, if I have my electrons further away from my nucleus, there's not going to be as much of an attraction there. Whereas if they were really close, they're going to be really tight together, really stuck together, really feel one another. If they're further away, they won't. And that's going to be a big point that we're going to make here in the next part of our paper.